So this is a problem statement. So I'm going to solve this. So we'll take a new program in Indralogic. Here, first we are going to declare the variables. Actually, we can do this way. Say, for example, we can see the timing diagram. Okay, timing diagram. So this is a timing diagram. So this is input. Input you can take it. X-axis time and this is time, and when input is on and when input is off, as soon as input is on, output will be on, that is M1, and M1 is on for 5 seconds, right? So here this is start button, when you operate start button, and this is T. Okay, and this one is M1, M2, then when motor 1 is off, at that same time motor 2 will be on, and it is on for 5 seconds. On for 5 seconds. Then after that, again when motor 2 is off, motor 3 will be on, and it is on for 5 seconds. This is called the timing diagram, input-output timing diagram. So here to here, So what is the time length here? This is 5 seconds, and this one 10 seconds, and this one 15 seconds. Okay. So this is a timing diagram, and this it could be shorter also. It's a very short signal. It's briefly you're operating, right? Even it is very short. Just a pulse you're giving it. So this is a timing diagram. So based on this timing diagram, I can draw the logic. Okay. So go to the Indralogic. So here I'll take one start button. So what is the address? Percentage IX. In your case it is 1.0, but here I don't have a hardware. I'm using the onboard IOs. So 0.0 I'm doing it. Okay, while you are practicing, you take 1.0. Percentage IX 0.0 I've taken. In simulation mode, it will work. Okay, if you get an error of invalid address, that means you are missing the inline. Okay. Should I put the same address 1.0? You want that? Okay, I'll use the same 1 minute. Shift F2 to change, to edit the address, or to change the address. I'll make it percentage IX 1.0, and so I'll go to the PLC configuration and I'll add the inline modules DI 16, DO 16. Okay, that's a regular procedure already explained before. So now when you press start button, what is your immediate programming is required? See, S1 start button and stop button is up, both are push button. Okay, so those signals data will be erased or will be lost as soon as you release the start button. Okay, so what you have to do? First you have to store that start signal in some location, memory location. Okay, so to do that, I'll take one memory bit here, that is say M1. M1 is marker or internal relay, and don't type any address, or if you want to type, you have to type percentage MX. Okay, otherwise don't type. It will assume that it is a internal variable. So click on OK. I'm not typing address. Click on OK. Next, what is the storage logic? You should have a parallel contact, same as output here. That is M1. Correct. And when data should be erased, start signal should be erased by operating stop button. So stop button is another input, is a real input. So percentage IX 1.1. Because if you refer the diagram here, throughout the length of 15 seconds, okay, start signals should be stored. Correct, right? So I cannot hold for a long time. So I'm storing the data to M1 memory bit, so that it is continuously on. So this much I'll simulate it now. Go to online, simulate, simulation mode, then go to online, login, run. If you press start button once, signal is stored. Even if you switch off the start button, continuously M1 is on. This is okay? So it depends upon the nature of the problem statement. You should design the circuit. If there is a toggle switch in the problem statement, then this is not required. Directly you could have started, right? since it is a push button, I have to internally store the data. Okay, so once it is done, we know that M1 will be on continuously. Once start button is operated, M1 will be continuously on. So M1 is a reference for me. So what I'll do is, when M1 is on, immediately without any delay, motor 1 should be on. Correct, right? Instead of taking M1, because M1, M2 we are planning for motor, so you can take a hold variable. Hold means it is holding the signal. Just put it here, and just you also copy here. Okay, because I want to reserve the name M1 to the motor. Next, when hold variable is on, so what is your immediate requirement? I want to switch on M1 without any delay. Okay, so I'll take motor 1 or M1, motor 1, and address, it's a real output, so percentage QX 1.0. Okay, so when you press start button, without any delay, motor 1 will be on. It is continuously on. So what is our requirement? Motor 1 should be on for only for 5 seconds. Correct, right? So after 5 seconds, there are two actions. What is that? M1 off, M2 on. See the diagram here. At 5 seconds, M1 should be off, M2 should be on. Okay, so now I will take the reference. For me, reference is start. Start is nothing but internally hold variable. So when hold variable is on, I'll go count the time. So library is missing here. Standard library. Then here take timer. I'll take on delay timer. Say T1. That's the name of the timer. Function block. Click on OK. Don't type address there. The time T hash 5 seconds, and if you want to read the time, then D1 for timer 1, and type of the variable should be time. Okay, so after 5 seconds, what is your requirement? M1 off, motor 1 is off. Off means you have to use normally close. On means normally open. So since motor 1 is required to be off, I'll take normally close before M1, and what is the, after 5 seconds, timer will be on. So T1.Q. After 5 seconds, this will be open, so that motor 1 will be off. After 5 seconds, we want to switch on. So T1.Q, I'll copy paste it here, and then I'll take another variable, that is motor 2. Motor 2 address is percentage QX 1.1. Right? Next, see the diagram. What is requirement? After 10 seconds, motor 2 will be off, motor 3 will be on. So using this diagram, so what is my reference? Well, what do you mean by 0? 0 is nothing but like hold, start signal. Start signal is a 0 time. So that is a reference. Or okay, hold variable, and then you take another timer T2, click on OK, and here time is t hash 10 seconds. And here D2, D2 for timer 2 time. So after 10 seconds, what is our requirement? T2.q. 1 minute. Should I simulate this much? Okay. See, right now motor 1, motor 2 both are there. When you press start button, motor 1 is immediately on, even if you release the start button. After 5 seconds, motor 1 is on, motor 1 is off, motor 2 is on, and motor 2 is continuously on. That we don't want that. So after 10 seconds, T2 will be on. So I want to switch off motor 2. Off means normally close, and I want to switch on. Motor 3. Motor 3 variable, you have to take it. Address percentage QX 1.2. Right? You want to simulate this much? Then go to online, log in. Actually, motor 1, motor 3. This is motor 1, motor 2, motor 3. Now press start button and release. Motor 1 is on. Next, motor 2 is on. After 10 seconds, motor 2 will be off and motor 3 is on. Okay. But after 15 seconds, now motor 3 is continuously on. We are not programmed for motor 3. Okay. So next is same variable, that is in my reference, T3, okay, and T hash 15 seconds, and this is D3, it should be time variable. So what is the requirement? After 15 seconds, I want to switch off motor 3. Correct? And what is the other requirement? So after 15 seconds, motor 3 is off, plus it should repeat. Motor 3 should be off, motor 1 should be on again. So we will take one minute. So cycle should repeat. How we can do it? All timers we can reset. So just before all timers, we can have T3.q. T3.q, and here also, because if you erase the data, means if you switch off hold variable, then you have to operate start button again. That I don't want to do it, right? So run, and 3 motors are here. So motor 1 is on, motor 2 is on, motor 3 is on. After 15 seconds, motor 1 is on again. Okay. If you reset timer, all three timers, it starts from 0 again. Because when you reset all timers, even T3 also reset, T1 also reset, so start from 0. Because the variable hold is continuously on. Is it fine now? It's keep on going, but if you press stop button, see what happens. If you press stop button, everything is off. It is stopped, process is stopped. Okay, now I will add visualization to this process, means this logic. Okay, so I want to display how many inputs are there? 2 and 3 outputs. So now we have to design the screen for this. So for that, what is the first step? 2 input and 3 output, those address should be declared in the global variable. Okay, so that its status can be updated in the visualization screen. So how to do that? So here are some variables. I'll copy all variables. I'll copy and then go to resources. There is a global variables. Global variable here, and then enter here, and then paste it, all variables. Okay, and next go back to the program, go to the visualization, add object, and here name is motor sequence visualization, but motor sequence is okay, or you can put particularly 3-motor sequence. Okay, there is some motor sequence. So now I have to adjust the screen here, and this is a screen I'm giving for program. This is a screen. Okay, and here so I'll copy 3 times. Three motors, and this one colors you want initially red or initially gray type, and then it goes to green, then go to variable, change color when it is motor 1 variable. You want to display some text. Yes, it is motor 1. Font size, just increase it. Oh, it is too big, and reduce the font size. It is okay. So everything should, just like and color inside gray type, and then it is green. Okay. I've created 3 motors, so that is where to rename it. This is motor 2, and in the variables, in the variables, change color when motor 2 variable. You should remember the variable name. This is motor 1. This is a very case sensitive. Variables are case sensitive. While typing, if you type small letter M and then motor 1, so it will not link. Motor 3. So now motor 1, motor 2, motor 3, and buttons will take 2. This is one start button and stop button. Okay, so here text I want to name it as start, and colors, okay, color it's not there. Variable for input, it's a tab variable, that is start. Start, and this one it's a tab variable, it is stop. Text is okay, start stop is there. So now we are going to simulate it. Run. If you start, motor 1 is on for 5 seconds. Motor 2. So now it's a better experience. Like visualization is added. So you don't have to go down to the program and check. So 3 outputs we can check it here. Conditions. But I'm checking how to display the time also. Here time, for example, display, you can display time. It is counting. So that is also a better experience, but I'm not finding that option. So those kinds of features will be there in the SCADA screen or HMI screen. Okay. So here some features are limited, but okay, visualization is possible. Okay, now press stop. Everything is going to stop. Is it okay? This is solution 1. This is one solution, but there are many solutions. One more solution is I use 3 timers. You can use 1 timer. Additionally, comparators you have to use it. Right. So some students already done it. So using single timer, using comparator also can be done. So that I'll take up in the next session. But this is what. Any questions here? And whatever procedure I have done here, it's already recorded. It's recording actually. Same thing will be available to you. Okay. You can refer it. So I have step by step I clearly explained why line 1, why line 2, why line 3. So this is only for the beginners. Okay, after that, okay, once you get the idea how to use the commands, then later on on your own you can develop the solution. Okay, clear?